For topic two, we're going to discuss evaluating algebraic expressions. This is something that's going to come up quite a bit, and understanding how this works is going to be really powerful. So we'll start really basic, and I'll hopefully, hopefully I'll be able to incorporate evaluating algebraic expressions in several of our chapters. So again, once we get to that point, that chapter in this book, it won't be quite so daunting. So the first thing you need to understand is, what is evaluating? Like, what does that mean? Okay. Evaluating an algebraic expression is the process of replacing the variables with given values. So you're going to replace all of the variables with given values. So you don't have to pull these values out of thin air. You're going to be told, hey, what would this expression equal if the variable equaled blah? Okay. So we're going to replace all the variables with given values, and then we're going to have to use the order of operations to simplify. So we discussed the order of operations in the previous chapter. So hopefully it's still kind of fresh because it was right at the end of the last chapter. So for example 2, it says evaluate each expression for the given value. So that's all we have to do here. Now, I will tell you, when you're evaluating an algebraic expression, you're just going to get a final answer that is just a number. So at the end of this process, you shouldn't have any variables left. You should simplify down to just one single value, okay? So for part A, it says we have the algebraic expression 5x minus 2. And then they have a little semicolon, or semicolon, and they say, okay, x equals 9. What this is really saying is evaluate 5x minus 2 when x equals 9. So what does 5x minus 2 equal in the event that x is exactly 9? So what we want to do is we want to rewrite this expression, and anywhere you see an x, we're going to use parentheses and replace it with a 9, okay? So I have 5 times x, but x is really 9. And then from that, I want to subtract 2. Now, you also need to remember that in the world of order of operations, parentheses typically mean grouping symbols. But for a set of parentheses to be grouping symbols, you would have to have addition or subtraction or multiplication or division or something inside those parentheses. If you just have a single number inside parentheses, the parentheses typically indicate multiplication. And that makes sense here. We have 5 times x, so when we replace x with 9, we have 5 times 9. Now, for the order of operations, remember, it's PEMDAS. Please excuse my dear Aunt Sally if that sticks with you better. The P stands for grouping symbols. We don't have that here. The E stands for exponents. We don't have that here. The M and D kind of go together, and that stands for multiplication and division. And we do have multiplication. We have 5 times 9. So 5 times 9 is 45. So I'm going to replace 5 times 9 with 45 and then just bring down the rest of the problem. Now we have one step left. It's addition or subtraction is the last step to the order of operations. And so we've got one subtraction here and then we're done. So 45 minus 2 is 43. So if we take the expression 5x minus 2 and evaluate it for x equals 9, we would get exactly 43. Notice the x is gone. The x gets completely replaced with that value, 9. Let's look at part B. So notice in part B, we have 2 variables here, okay? We have 4, and then in parentheses, we have x minus 9. And then we have the semicolon, and it tells us that x equals 11 and y equals 5. What that is saying is evaluate this algebraic expression when x is 11 and y is 5. So basically, take this algebraic expression, tell us what it equals if you replace x with 11 and y with 5. So we're going to rewrite the expression. Anywhere we see an x, we're going to plug in an 11. Anywhere we see a y, we're going to plug in a 5. So we get 4 times, well, x is 11. From that, we want to subtract y, which is 5. And there you have it. We can follow the order of operations from here. So remember, PEMDAS, the P stands for grouping symbols, or parentheses is really what it stands for, but we think parentheses and expand it to grouping symbols. Well, we do have a set of parentheses here because inside this set of parentheses, we have the operation of subtraction. So the very first thing we want to do is take care of 11 minus 5. Well, 11 minus 5 is 6. So I'm going to rewrite this entire expression, and where I have the 11 minus 5, I'm going to replace it with a 6. So I get 4 times 11 minus 5 is 6. And this gives me one final step, which is just multiplication. So 4 times 6 is 24. And there you have it. Okay, so we have evaluated 4 times x minus y for x is 11 and y equals 5, and we get exactly 24. Let's look at part C. So part C looks like a fraction, but don't fret. It should simplify out beautifully because at this point we haven't dealt with fractions. So until we deal with fractions, if you see something that looks like a fraction, remember it just means division. So we have y plus 6 divided by x. We want to evaluate when x is 2 and y is 8. So I'm going to rewrite this exact expression, and anywhere I see an x, I'm going to put in a 2. Anywhere I see a y, I'm going to put in an 8. So I get y plus 6, which is really 2 plus, whoops, don't do that. Boy, I about messed that one up, didn't I? We have y plus 6. Y is 8 plus 6, and we want to divide by x, which is 2. And then for something like this, simplify each part. Simplify the numerator completely, and then simplify the denominator if you need to. So in the numerator, we have addition. So we want to take care of 8 plus 6, which is 14. The numerator being the top part of the fraction, we call the bottom part the denominator. The bottom part of the fraction is 2. And remember, this really just means divide. So we want to come down here and we could say, okay, well, 14 divided by 2 is 7. So if I take the expression y plus 6 divided by x and I evaluate it when x is 2 and y is 8, we get 7. All right. One more, and this one might be a little bit tougher because we do have an exponent. So we have the expression x squared plus 4x minus 5. Anywhere we see an x, we want to replace it with 3. So we are told here to evaluate this expression when x is 3. And anytime you have an expression where there's multiplication involved with a variable, you do need to use parentheses. So I'm going to use, instead of x over here for x squared, I'm going to use parentheses, and I'm going to write the x as 3 and then squared. So that's how you would write that as far as the evaluating and the replacement goes. And then I have plus 4 times x. So I'm going to use parentheses to indicate my multiplication. I'm going to let x become a 3. And then don't forget we have to subtract 5. Now, the order of operations, remember, it is PEMDAS. So we have P for parentheses or grouping symbols. We do not have parentheses that are grouping symbols here. We have parentheses that indicate multiplication, but we do not have grouping symbols. Remember, for it to be grouping symbols, you'd have to have addition, subtraction, multiplication, or division inside the parentheses. We don't have that. So we want to move over to the E. E for exponents. We do have that. So over here to the side, remember, 3 squared is really just 3 times 3. So we've got 3 times 3. Well, 3 times 3 is 9. So I'm going to rewrite this entire expression, and instead of 3 squared, I'm going to replace that with a 9. So I've got 9 plus 4 times 3 minus 5. So we've taken care of the P. We didn't have that. We had the E. So now we're down to the MD step. We do have multiplication. So let's go ahead and take care of our multiplication. We have 4 times 3, which is just 12. So I'm going to rewrite the entire expression. I'm going to replace 4 times 3 with 12. So I've got 9 plus 12, and then don't forget to drop down your minus 5. And finally, we're at this point where we have addition and subtraction. And when you have addition and subtraction, you can do them at the same time. You just work from left to right. So in this case, we have addition first. So I'm going to take care of my addition first, my subtraction second. So over to the side, we need to do 9 plus 12. So if you can do 9 plus 12 in your head, great. Do 9 plus 12 in your head. If you still need a little bit of help, you could do 12 plus 9 over here to the side. 9 plus 2 is 11, so I want to keep a 1, carry a 1, and then 1 plus 1 is 2. So 9 plus 12 is 21. And then finally, we have 21 minus 5. Again, 21 minus 5, ideally, you could probably do that one in your head. If not, do a little side work. There's no shame in that. We have 21 minus 5. I cannot take 5 from 1, so I would borrow. So 2 becomes a 1, 5 becomes an 11. 11 minus 5 is 6. And then 1 minus really nothing is just 1. So at the end of the day, when we have x squared plus 4x minus 5, and we evaluate it for x equals 3, we end up getting 16. So just understand when you see the words evaluate, when you're talking about algebraic expressions, you're going to be given values for the variable. You plug them in. You just replace your variables with those given values, and then you use the order of operations to simplify.